Okay, the last thing for adding, subtracting rational expressions is complex fractions. This is not as hard as the unlike denominators thing. I think, well, the unlike denominators is by far the maybe most time consuming, maybe most difficult. I don't know. I'll leave that up to you to decide. But complex fraction contains one or more fractions in its numerator, its denominator, or both. Examples of complex fractions are shown below. Where? What do you mean? Oh, right there. Look at that. Basically, fractions with fractions. Fractions of fractions. Not as tricky or as difficult to solve as maybe they look. It's all about kind of how you rewrite the problem. Rewrite the problem and you're golden. You just have to, we'll talk about how you would rewrite it. And it goes back to the whole division thing. If you remember dividing rational expressions, how we did sort of a keep, change, flip. That's going to be kind of useful to us here. So, but of course, we do have to keep in mind if we're adding, subtracting stuff, different fractions together, that we have to have a common denominator. So look for those as well. All right, these problems look extremely different and squished, but that's fine. So assume that all expressions are defined. Who cares? Okay, so basically what this says in this first example, example 13, which is already there for some reason, it's kind of saying like this divided by this. So if that's the case, so I would rewrite it like this. I would keep this x plus 2. I mean, you have to keep this. Not that I'm choosing to keep it, but it's how it works. X plus 2 over x minus 1, right? Keep that. Change the fact that I'm dividing here to multiplying, right? And then multiply the flipped version of this. So that would be the x squared minus 1 on top and the x squared. Is that an x squared? Yeah, an x squared minus 4 on bottom. So it is kind of like the same thing as division. It really is. It's just written differently. So it is division, but you keep this, you change it to multiplication, and you flip that. That's basically all it is. So factor and cancel, back to what we did before. Why is this an adding, subtracting again? I don't know, but it just is. So we have x plus 2 over x minus 1. Nothing there is factorable, but the right side is. So x squared minus 1, that is difference of squares. That factors in the x. That factors in the x plus 2 and x minus 1. I'm sorry, what am I saying? X plus 1 and x minus 1. And the bottom also difference of squares factors in the x plus 2 and x minus 2. So everything's factored. Let's see if I can cancel out. So I can cancel this x plus 2 with this x plus 2, and I can cancel this x minus 1 with this x minus 1. So, and I can do that because I'm multiplying. Remember, when it comes to multiplying, you can cross cancel. You cannot cross cancel in adding, subtracting, but you can cross cancel when you're multiplying. So those cross cancel, those go away. So it leaves me with just x plus 1 over x minus 2. Jeez, I hate it when it does that. X plus 1 over x minus 2. That's it. So let's look at, I guess, example 14. Ooh, there it is. Let me erase this. Okay, you know what? It's just getting messy. I make too many slashes. All right. We'll use Sydney Blue, because why not? So 6x, x squared minus 1. So remember, we'll keep this. We'll change this to multiplying, and then we'll flip this. So this, I'll rewrite it as 6x over x squared minus 1 times, and then the flipped version of that bottom part. So x minus 1 on top, and then x on bottom. So if I simplify, factor, and cancel here, we'll have 6x over the factored version of this would be x plus 1. Ah, man. X plus 1, x minus 1. And then there's nothing to factor in the second side. It's x minus 1 over x. So notice this x minus 1 will cancel with this x minus 1. This x cancels with this x. It's not really attached to that 6 because it's not plus 6. If it was plus 6, it would matter. But it's 6 times that, so they're both kind of free and independent, do what they want to. So those x's cancel because at 1x over 1x goes away. And so we just have 6 over x plus 1 as a result there. All right, now it gets a little more interesting because notice we're adding this on top, so we will have to simplify that probably first. So let's go ahead and do that. Notice these already have common denominators, so if I would want to just add these up, I would just do 1 plus 3, which 1 plus 3 would be 4 over 2x. Which actually that's sort of simplifies to just 2 over x. X is still in the denominator, so but that numerator simplifies to 2 over x. So we have 2 over x. That's my keep that. I'm going to change the bottom part. I'm going to multiply it, change it to multiplying, and then flip the bottom part. So 6x squared over 4x plus 8. So hopefully you followed. I did a lot there. I added these up, by the way, if you're wondering. 1 over 2x plus 3 over 2x. Common denominator is 2x. 1 plus 3 is 4. 4 and 2 both reduced by 2, so I did that. 4 divided by 2 is 2. 2 divided by 2 is 1, but the x is still there. So that's the 2 over x part. That the whole top part here is just 2 over x. And so I just kind of changed it to that, reversed the multiplication, and then flipped my bottom fraction. So it's a couple things here, but let me factor the denominator here. This denominator. Factors, you can divide a 4 out of it. So we'll have 4 and then x plus 2 if we factor that out. So a couple things. Let me go ahead and multiply it together and then cancel out. I think that'll be a little easier. So on the top, 2 times 6 makes 12 and then x squared. On bottom, I'd have x 4, so 4x and then x plus 2. So I know 12 over 4 will reduce to 3 over 1. An x on the bottom will cancel with it. One of the x's up there, leaving you with a single x up on top. And then you just have this x plus 2 sitting here still. So a simplified version of that would be 3x over x plus 2 as a final answer. Kind of weird. There's a lot of weird things that happen there. They're not difficult, but they can be a little bit off-putting, for sure. So be careful of that. All right, and then let's do one more to wrap it up with. So I do have to add these up first. Let me do that. So 3 over x plus x over 2. Now remember, there's no cross-canceling when you're adding or subtracting. So you can't just go, oh, those cancel out because you got that plus sign there. So be aware of that. So you have to have a common denominator first. So I notice, I need to multiply this denominator by 2. So I can match this 2. And I need to multiply this denominator by x, so it matches this x. So I can have 2x as my common denominator. Now, having 2x as a common denominator means that I need to multiply this top part by 2, which makes that 6, and this top part by x, which makes it x squared. So that means when I add them up, they're not like terms, so I can't actually combine them. I'll just have x squared plus 6, and then over my common denominator of 2x. So that's the top part. The top part here is x squared plus 6 over 2x. And the denominator there is still x minus 1 over x. But we'll flip that in the next part of this problem. Okay. So getting rid of all that mess. So let me rewrite this. I'm going to keep the x squared plus 6. That's the part I keep over 2x. I'm going to change the fact that I'm dividing into multiplying, and then I'm going to flip the bottom. So the bottom, put the x on top and the x minus 1 on bottom. I don't see much canceling out here. So yeah, I think when I multiply, nothing factors. The only things that'll cancel would be this x here cancel with that x there because they're both free and independent, do what they want, okay? So those can go away. But other than that, I don't see anything that cancels. So my answer will be x squared plus 6 over 2 and x minus 1. Yeah, that should be it. All right, I think I'll end the video there. I think I get the point across. I don't know if there's anything more anyway. So, yeah, that was it. I'll leave it there. I'll see you guys later. Bye.